Hello and welcome to our lesson on dividing fractions and mixed numbers. So before we can divide fractions and mixed numbers, we have to know how to find the reciprocal of a fraction or a whole number. So what is a reciprocal is what we're going to talk about first. Okay, so two numbers are reciprocals of one another if, by definition, their product is 1. So if we multiply two numbers, we get this product of 1, we probably have reciprocals, okay? For instance, if we were to multiply 2/5 and 5/2. So if I multiply 2/5 and 5/2 using the multiplication process we talked about in the previous topic, multiplying on the top here, we're going to have 2 times 5, and multiplying on the bottom, we're going to have 5 times 2. Well, that's going to be 10 on the top, and that's going to be 10 on the bottom, and 10 divided by 10 is going to become a 1. And we can also see that these would reduce, and that these would reduce, and we'd still be left with 1, so if we went about reducing it first, we're going to end up with 1. And the same thing happens here. 7 times 1 on the top of the fraction, 1 times 7 on the bottom, means 7 gets divided by 7, and that, again, results in 1. So two numbers are reciprocals if their product is 1. And to find the reciprocal of a fraction, we can see if 2/5 and 5/2 are reciprocals, or 7/1 and 1/7 are reciprocals, to find the reciprocal of a number, all we have to do is interchange the numerator and denominator. If we just swap them out, flip-flop it, interchange our numerator and denominator, we will find the reciprocal of a fraction. So the reciprocal of 3/4 would be 4/3. Let's just interchange the numerator and denominator. Now, if we have a whole number like 8, we have to remember that dividing 8 by 1 doesn't change its value, so I can make my whole number 8 a fraction by putting it over 1, and then its reciprocal would be 1/8. So 8/1 and 1/8 are reciprocals, 3/4 and 4/3 are reciprocals. Okay, that's the concept of a reciprocal, which is going to come back in just a minute. Now let's talk about the concept of dividing fractions. To make this make sense, let's start with whole numbers first. Remember, if we're dividing 10 by 5, 10 divided by 5 means we want to know how many groups of 5s are there in 10. So we have this block of 10 here, so there's 10 altogether. If I wanted to divide that by 5, find out how many groups of 5s are in here. Let's see, 1, 2, 3, 4, 5. There's one group of 5. Right, and then 1, 2, 3, 4, 5. There's another group of 5. So we know that 10 divided by 5 is 2 because there are two groups of 5s in 10. Okay, so if we take this now to a fraction, if I said to divide 10 by a half, that means I want to know how many halves are there in 10. So how many halves are there? Well, here's one whole, okay? Which means there are two halves in the one whole. And here's another one, and there are going to be two halves in there. And there's another one. There are going to be two halves in there. So each one of the wholes has two halves. So I've got two halves here. I've got two halves here. I've got two halves here. And there's going to be another 2 and 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 another, a whole bunch of halves in there. And precisely how many? That's 1, 2, 3, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 halves throughout this picture. So therefore, dividing 10 by a half is going to be 20. Now notice, if we took 10 and we multiplied by the reciprocal of a half, what is the reciprocal of 1/2? Oops. The reciprocal of 1 over 2 of 1/2 would be 2/1. If I took 10 and I multiplied it by the reciprocal of a half, I get 20, which is the same as dividing it by half. So the general rule of dividing fractions is to multiply by the reciprocal. Right? 10 divided by a half is 20. 10 multiplied by 2 is 20. And 1/2 is the reciprocal of 2. So multiplying by the reciprocal, dividing by the fraction give us the same result. All right, so we are going to say to divide fractions, we multiply the first fraction by the reciprocal of the second fraction. So if we're taking something like a over b divided by c over d, we're going to keep the first fraction the same. So a over b stays a over b. The division is going to become a multiplication problem, and then we are going to multiply by the reciprocal of the second fraction. So c over d flips to d over c. And then we have a multiply problem, and we know how to do that already. We multiply the tops, we multiply the bottoms, so we simplify if we can. So we want to make sure that our answer, our final product, is a fraction that's in its simplest form. Okay, so let's try this out. If I want to know how many 2/9 are there in 7/8, I don't want to have to draw this out every time. That'd be a complicated picture to try to make. But we know that this is going to be the same result of multiplying 7/8 by the reciprocal of 2/9. So we're going to keep our 7/8. We're going to take our first fraction and we're going to multiply by the reciprocal of our second fraction. So we keep the 7/8 the same. We're going to change our division problem to a multiply problem and make the reciprocal of the second fraction. So we're going to be flipping that 2/9 to make it 9/2. And now we have a multiply problem. So we're multiplying 7 and 9 on the top of the fraction. We're multiplying 8 and 2 on the bottom. 7 times 9 is going to be 63. 8 times 2 is going to be 16. And we're not going to have any common factors there. So 63/16 is going to be our result. Okay, and then remember, this is a skill we should have, but we do have calculators that will verify what we're doing. So if we said, hey, Desmos, take 7/8 and divide it by 9/2, it looks a little crazy in Desmos, but it will give us that. Oh, sorry, it's divided by 2/9. I'm like, what did I do? Let's put the original problem in, and Desmos will tell us that 63/16 is the result. Okay, now remember the divide, it doesn't like the divide button in there, it makes fractions automatically, but that is saying the same thing. 7/8 is being divided by 2/9, and there it is, 63/16. Okay, so let's try this again. We are going to find out how many halves are in 2/5 by multiplying by the reciprocal of a half. So we keep 2/5. Make this a multiply problem, and we want the reciprocal of the second fraction. So the reciprocal of 1/2 is 2/1. And that means we are multiplying 2 times 2 on the top, and we're multiplying 5 times 1 on the bottom. 2 times 2 is 4, and 5 times 1 is 5, so 4/5 is our result. Okay, so there's 4/5 of a 1/2 in 2/5, which is just, yeah, it's weird to even try to say that. All right, let's try this next one. So 5/16 divided by 3/4 is the same as 5/16 times 4/3, which means we're going to be multiplying 5 times 4 on the top, and we're going to be multiplying 16 times 3 on the bottom. Now I can see some common factors in this one. I know that 16 is the result of 4 times 4, so I'm going to rewrite this. Oops, let me get my pen back on. So this is 5 times 4 on the top, and 16 I know is 4 times 4. So instead of 16, I'm going to make this 4 times 4. That way I can reduce, right? I can reduce a 4 and a 4. We can the pair of 4s here can become a 1s because 4 divided by 4 is 1. And so what are we left with? 5 times 1 on the top of the fraction is going to be 5. And 4 times 1 times 3 on the bottom is going to be 12. So 5/12 is going to be our simplified form of the answer. Okay? So it's really just a multiply problem. If we have a divide problem, we're going to rewrite it, and then we have our multiply problem. Okay? Now, if we have fractions and mixed numbers or whole numbers together in a division problem, then we want to take our mixed or whole numbers and write them as improper fractions before we do any of our work. So just like with the multiplication, right? Any mixed numbers or whole numbers we're going to rewrite as improper fractions first. And any whole or mixed numbers must be written as improper. I don't know why I didn't put the word in here, but that should be fractions. And then once we have those numbers rewritten, we can multiply just like we did on our first 3 examples. So first, if, for example, on number 4, if I have 3/4 and I want to divide it by 5, I'm going to make 5 a fraction by putting it over 1. So now I can say this is the same as 3/4. 3/4 divided by 5 over 1 is the same as 3/4 times 1 over 5. And so it's going to be 3 times 1 in my numerator, 4 times 5 in my denominator. So that's going to be 3 over 20. No common factors. That's going to be our result. And let's try this again. So here, I'm going to want to fix this mixed number here of 2 and 5/6. Remember, we're going to multiply and add. So it's going to be 6 times 2 plus 5 over 6. And that's going to be, let's see, 12 plus 5 is 17. So 17/6 there. So this is really, this is really going to be 11/18 divided by 17/6. So I just made the mixed number an improper fraction. Now, to divide fractions, we multiply by the reciprocal. So this becomes 11 over 18 times 6 over 17. So we're looking at 11 times 6 in the numerator, and then 18 times 17 in my denominator. But again, I see a common factor here, and so I'm going to rewrite my 18. I'm going to make this 11 times 6, not changing that, but I'm going to make this 18 3 times 6. 18 is 3 times 6. That way I can reduce my common factor of 6. So 6 divided by 6 is 1, and 6 divided by 6 is 1. So what we're left with in the top of the fraction is 11 times 1, which is 11, and 3 times 1 times 17, which is going to be 51. And so 11/51 is going to be the result on that guy. Okay? All right. Let's try that again. We're going to change both of these this time. So we're going to multiply and add here. We're going to call 5 2/3 15 plus 2. Sorry, skipped a step. 3 times 5 plus 2 over 3. That's 15, 16, 17/3. And then here, if we multiply and add 9 times 2 plus 5 over 9, that's 18, and 5 is 23. That's 23 over 9. So this problem is really asking you to take 17/3 and divide it by 23/9. So we have 17/3 multiplied by 9 over 23. And remember, if you can see the common factor here and you don't want to have to rewrite them as factorizations, you can also use the division as a shortcut. So for instance, 3 divides into 3 once, and 3 divides into 9 3 times. So if you want to shortcut with division, that's going to be totally fine. So we're looking at 17 times 3 in the numerator and 1 times 23 in the denominator. So final result, 17 times 3 is going to be 51, and 1 times 23 is going to be 23. So 51 over 23 is the result on that one. Okay? Fun math, right? I got one last example. It's a word problem, but it's the same thing. It says, in a manufacturing process, a metal cutting machine cuts strips that are 1 3/5 inches wide from a piece of metal. How many strips can be cut from a 48-inch piece of stock? So you have some piece of metal. Let's see. You have this metal strip here, and it's 48 inches altogether. So 48 inches altogether. And the question is, how many 1 3/5 inch wide strips can we get out of it? So how many of these 1 3/5 inches are going to be in there? So we are going to take our 48 inches and we're going to divide by 1 3/5. We can see how many of those can we get out of that, right? It's precisely what division does. So if we were to convert this, 5 times 1 plus 3. 5 times 1 is 5. 5 plus 3 is going to be 8. So this is going to be 8/5. So we are trying to take 48. 48, I can make a fraction by putting a 1 under it. We're going to take 48 over 1, and we're going to divide it by 8/5, which really means we're going to take 48 over 1 and multiply it by 5 over 8. Now again, I can see in my common factor here, 8 divided by 8 is going to be 1, and 48 divided by 8 is going to be 6. So if you want to take that shortcut of reducing, that will save you some time. So it's going to be 6 times 5 on the top of the fraction and 1 times 1 on the bottom. So we have 6 times 5, which is 30. 1 times 1, which is 1. So 30 over 1, but that's kind of nice there. 30 divided by 1 is just going to be 30. So that means we can get 30 of those strips from that 48-inch piece of stock. Okay? So you'll see some applications maybe of some division, but for the most part, right, remember that if you are dividing fractions, you have to multiply by the reciprocal. So we keep that first fraction the same and make a multiplication problem when we flip the second fraction. All right, I think you've got enough to go on for your practice assignment, but as always, if you need some extra help, then just reach out. All right, guys, take care.